Hey, welcome back. Today on my bench I have an old workhorse of mine. This is a Sony TA-535 integrated amp, and this was my garage amplifier for the last 15 years or so. It's pretty rough shape. I think originally this was a dumpster find and a rescue, and I remember working on this when I first got it to get it going, just good enough so that I could use it as an amplifier and in the garage, feeding it whatever. But it's got a lot of years service, a lot of seniority. It's also got a lot of problems. And up until recently, I was tolerating the really very scratchy volume pots, the noisy switches that sometimes they die and then you have to work them a couple times to get them to come back. And there's scratchy pots. And it also had a really weak right channel for some reason. I used to have the balance control set way to the right to get any sound out of that right channel to balance it out. But I like this unit. It sounds good. It's got a lot of good features. Here, first let's look at the back. It's heavy. I'll go with that. What the hell is this thing? Anyways, so the back is pretty sparse. Like, look at that. We've got some 3 courtesy outlets, 2 sets of speakers, and we got very sparse inputs. We've got phono input, tuner input, and auxiliary, and then we have 1 input for cassette or tape, and that's it. Nothing else. It's pretty simple. But on the front, this is where the fun happens. We have a second tape input and output on the front using the 1/4" jacks, and we have the switch for it. So we have 2 tape monitors, auxiliary, tuner, phono. These are not the right knobs. I just stuck these knobs on because when I got it the knobs are missing, so I just threw these knobs on. These aren't the right ones. So it runs 2 sets of speakers. It has a microphone input, which I believe I disabled because I had no use for it. And what it is a stereo input for a microphone, and you have a mic mixing level, which is setting the level for your microphone, and it also has a microphone reverb level. It's got a reverb circuit in here so that anything coming in the microphone you can add reverb to it. So this would be a great karaoke unit for those who do that kind of stuff. My karaoke days are over, so I don't use that, but it's got reverb for the microphone or the source, so I can feed music in. I can feed it reverb level if I want that echoey noise. It's got a low filter, loudness, and it's got a minus 20 dB muting button, which I like too. I use that a lot when I want to quiet things down. I just press that button. It has a nice power meter here, LED power meter, and it's got 2 stages. One is let's see, on the lower stage it goes from 0 to 16 watts per channel. And when you turn the knob up high enough, it clicks on to the other stage, and it goes from 0 to 160 watts per channel, which a little excessive, but considering the specs on this, I believe, is 43 watts per channel. So let's have a look at the inside. What I want to do is I want to bench connect it and see what's going on with that right channel. If it is actually low, or if I had maybe a bad speaker wire or a bad speaker, I want to test that right channel out. I'm expecting, oh, I got the screws out. The lid comes right off. It's a dirty unit because it was in the garage for many years. It's filthy. It's got some big honking power caps in there, and the power amplifier board. Some 7-amp fuses in there too. That's pretty beefy. But this rat's nest here, this I want to go through and check capacitors, because I have a feeling this thing is how many years old now. If I can find a date code on it somewhere, it's probably pushing 35 years old or more. and it's got some dreaded output power packs. There's no discrete transistors here, so they use this. I don't know why they do this. It's these ribbon cables to connect from the power amplifier to the little subboard here for the power chip, and they got that extra 3-4 inches of leads there, which adds to crosstalk and impedance and all those nasty things that work against amplifiers. But anyways, I'll have to check all the connections on all these solder joints, and it's just going to be a general service. I'm not going to dump a bunch of money into this because it is a kind of a garbage garage amplifier that it's just there for severe service. You can see there's some collision damage here. I think I bashed it out just to make it look reasonable, and the bottom is all smashed in. It's got a few dents, and so this is not meant to be a centerpiece of your system. It's just meant to be a workhorse, and I want to get it back working again because I really like its performance. It sounds good, and it kicks out, and it's got some nice features that I use. And let's see what we can do here. First thing I want to do is get that right channel checked, connect it to a pair of speakers, and probably a dummy load, and feed it with some tones and see what's going on with that right channel. Okay, got it all wired in with dummy load, speakers, tone generator, and what else? Scope. Yes, scoped. Let's turn it on. Okay. What I have here is I have a tone on A. That's okay. Let's turn off A, which is dummy load. Scratchy that is. It just drives me nuts sometimes when I'm trying to. According to the meters, the right channel is stronger than the left channel, but that could just be a meter malfunction or imbalance. So let's turn off the sound, turn on the dummy load, and see. Let's turn it up to about 1 watt. Let's see what we got on the scope. Yeah, everything looks good. Everything's balanced and level. Let's keep going. Scratchy pots, yes. And the blue line is the right channel. You can see it's quite scratchy there. Sometimes you don't even get a signal out of the pot. And it just keeps going. I'll keep going up. There's some clipping, I think. Let's turn this down. Okay, I'm clipping both channels. Let's back this off a bit. Right about there. And the power meters, this one's at 20 watts on the left channel. Right channel says 40 watts. So I'm going to believe that meter is out of balance. There's an adjustment for it. But I want to check the output here while we got it turned up. Now for the left channel, I'm getting 20.4 volts, 20.5 volts actually into an 8 ohm load. Seems like it's doing well. Let's try with a higher frequency. Let's go up to 15 kilohertz. We'll try this again. $15 kilohertz. Turning it up. Clipping. And we're at 19.5 volts RMS on the left channel. So definitely struggling at the higher frequencies. Just gonna let this cook for a while at full power output. And I'm going to check the other channel. The right channel is putting out 19.75 volts RMS into an 8 ohm load. Left channel is 19.2. So maybe there's a little bit of an imbalance. Not much. Balance pot scratchy. Bass. Nothing doing. Doesn't seem to be working. Oh, not at 15 kilohertz it won't. Treble. Treble's working. Okay. Let's turn this back down to 1 kilohertz. Okay. I think the main thing with this thing is the volume pot is just terrible. Look at the scratchiness when I just move it, just touch it. That right channel just freaks out. So I'm going to have to do a clean on that. I want to test out this reverb. You hear that screeching? That's from the reverb unit. It's got a spring in there. 2 transducers and a spring. Let's turn it up, see what it does to the... It's not even connected. Doesn't do anything. Minus 20 dB muting. Perfect. So, I think it's just a tired old amp that needs a recap maybe, or a good checking over, and pot's cleaned. And okay, so I got the volume pot out, and let's just give it my usual clean. First we'll lube the shaft. Because it does feel stiff on the when you're spinning the knob. Okay, get a little bit of contact cleaner in here. So they got interesting. It's got 4 pots ganged up here on the same. Actually, no, 3. One of them's not. These 2 are the main ones, and then there's another one back here that's being used for something else. I think it's used for the meter, to be honest. And this is mounted, it's got dust on the bottom of the board. I think this thing sat for many years upside down because it's got dust on the bottom of the printed circuit boards. Okay, I think that's good for cleaning. Let's get some deoxit fader. And if I can get a drop in here. You can't see that, can you? And on this one I want that should do the business. Feels a lot better. I could lubricate the little detent ball thing on the back. A little bit of oil on there. Okay, I think I'm going to leave that alone. It looks pretty good. Got a lot of crud come out of the black crud come out of the shaft bearing. Let's reassemble this and put it back together. So while I'm in here, I want to do the balance pot. This is the balance pot, and these are the two reverb controls. So I took out a couple screws and pull this out. It looks like it's buried. I have the reverb unit sitting on top here, and it's mounted on a foam block to isolate it from mechanical shock and vibration. This is your inputs, outputs. Don't know which is which. But the pot I want to get at is under there, and it's surrounded by... So I'm going to take these three nuts off and remove two screws. And this whole thing should come off. So I'll get on that. So I removed this bracket and the reverb unit and just let it drop, and then I got full access to these three pots. I'm only really interested in the balance pot right now, but I could probably clean them all. Why not? That one's really... It needs oil on the shaft too. These ones are all... Okay. That's a lot better. Okay, let's hit it up with some deoxit. Probably used too much. Right on the contact slider. Okay. So I'll repeat that on the other two. Here's the connector for the mic input, and it got broken. And it looks like somebody's tried gluing it because there's glue, just dried adhesive around here. But it broke. So what I did is I just taped it up and shoved it in. I don't use it anyway, so just so it doesn't short out on anything. And I'm not interested in changing out that 1/4-inch input jack. I'm just going to leave it like it is. Okay, I'm working my way through this amp. I'm just going board by board. I removed the this board here is for the reverb, and it had a balance pot on it, so I removed that, cleaned it, put it back together. I removed this board because it's got the bass and treble controls, and I wanted to clean those as well as two of these switches were scratchy, so they got cleaned. And I went through ESR meter, checked capacitors. For the most part, they're very good, except I did find two capacitors. Where are they here? It doesn't really matter, they're all the same. So I found two capacitors, and you can see this on the bottom. They got stuff leaking out of them. I don't know if the stuff leaking out of them or what that is, but they tested bad on my capacitor tester, meaning that they're open circuit, high ESR in what was it, 2-3 mega ohm range, or 2-3 kilo ohm range, and capacitance is gone. These are 3.3 microfarad 50 volts. And these are in the signal path. I suspect these are audio grade caps because they're red, and then a lot of these other ones are blue. The blue ones just being regular caps. They're Nichicons, run-of-the-mill caps, and these ones don't have a brand name on them. Maybe they're Nichicons as well. But I suspect these are audio grade. So anyways, what I did is I removed the bad cap, replaced it with a audio grade cap, and what I did is I removed the complement capacitor from the opposite channel and replaced that one as well, so that we have two brand new capacitors in that circuit for both channels. And I did that in two spots, so I got 4 brand new capacitors in here. The rest of these other ones checked okay, and I went through, did the solder joints. Looks like I have been in here before cleaning up solder joints, and for the most part I didn't find anything, but it doesn't hurt to touch up the suspect ones anyway. So I'll put this back together, and then it's on to the power amplifier, which is going to be a little treat in itself because it has to come out as one piece, and we'll see how that goes. But yeah, I'm thinking these two 3.3 microfarad capacitors, the ones that were shot, I think that might have been my problem with the not having the balance on both channels the same, and maybe this is the reason why the high frequencies dropped off when we did your test earlier. So we'll put those, we've got the new caps in now. I'll just reassemble this board back in, and then we'll move on to the power amp and the power supply. So the power amp board is just sitting underneath. There's a couple slots in the steel, and the board is just sitting in that slot. And at the top they have just these two little, I don't know if you can see those, they just lift up to unlock, and the board comes out. There's no screws. You just loosen it, and then bang, out comes the power amplifier. It's kind of a unique design for easy servicing. It's not really cooperating here though, but if I can get this out, there we go. And then it's all connected. Let's get these wires. These wires are, then you can flip it over and do all your testing, which is kind of unique. Except, too much flexing, these will break, so you got to be careful with that. But I'll go through and I'll check solder joints and ESR on these caps. Okay, so I desoldered the main filter caps, and I'll show you why here in a second. I wanted to take them out. They have the conductive glue all around the bottom. It's all pretty much perished. And get rid of that. I want to show you the board here. I don't know if I can zoom in far enough so that you can see it. But you can see all this conductive glue. And then these two jumpers here that have green oxidation on them. Now, this is the power supply, the mains power supply, and it splits off the power to both sides for the power amplifiers. And these jumpers are actually main power rails to left and right channel, just because there's traces to jump over and stuff here. So I'm just going to clean all this up and put it back together and resolder it. And this is what happens when you get corrosion and you start poking around the screwdriver. You break the trace, or the jumper. So I'll replace that jumper. Now, since I got the power caps out, or the main caps, I'm going to test them just to see what the ESR is on these and how they're doing. These are, what are these? These are 8200 microfarads at 50 volts. So let's see what the tester says. So we're at 6800. It's quite a bit down from 8200. ESR is good. Let's test the other one. This one's doing a lot better. It's 7500. Same ESR. Okay, I think I'm complete everything I was going to do to this thing just to get it back into a reasonable working state. Clean the pots. I touched up a couple of solder joints that looked suspect, and then I replaced 4 caps. 2 of them were bad, 2 of them were complementary, so I replaced them anyway. But let's try this. Alright, so I got it all back together and got it working this time. I had broken a wire on the thermistor on the protection circuit, and couldn't figure out why the relay wasn't kicking in and providing an output. It's because I busted this little wire here and I had to rig in another one. This is my fault. I should have disconnected these leads when I had the power amp out. You live and learn, eh? So anyways, I got it piled into a signal here. Let's turn it up. You can see on the scope up in the corner. Let's see here. We have the only calibration on this. The only calibration on this amplifier or adjustment is for the power meter, and there's no adjustments for idling current. There's no adjustments for DC offset. There's nothing in the power amplifier to adjust, and there's actually no fuses either, which kind of, other than the fusible resistors. Anyways, so we got it at full power output right now, and I am measuring, clipping. There's clipping there. I'm going to back it off 1 notch on the volume knob. We got 18.6 volts RMS on the output. What I want to do is I want to jack up the frequency to see if we lose our high frequencies like we did last time. So I'm going to turn this up. Frequency, turn up to 15K. And look at that, it's rock solid. It hasn't dropped at all. Okay, so we're at 15 kilohertz. Turn it up to clipping. I'm getting 20.0 volts RMS. That's a stupid knob. It's got detents on it, and you can't get it in between that and that. Let's try it up a little higher. I'm going to go up to 25 kilohertz. Seems like it dropped off a bit, quite a bit. .3 volts RMS. Keep going to 30. It's 40 kilohertz. And I got 19. Oh no, hang on. 18.7 volts RMS. Interesting to see that this power meter is only showing 10 watts right now. If I drop the frequency, that comes back. .20 kilohertz. Yeah, it's back at 40 watts. But I'm also clipping a little bit. So a little bit of drop off on the high end. But I think it's better than what it was before. Those capacitors. I'll get a schematic out and I'll show you where I found them. I think we're done here. Muting works. Everything works. The knobs are clean. Volume knob is clean. So I think we're done with this. Alright, I just want to show you which caps I changed out here. This one here, 213, is a 3.3 microfarad 50 volt. This comes right out of the an audio frequency amplifier, and it goes through a 47 microfarad, and then it goes through the 3.3, and then this is the output signal into the power amp, and it goes into another 3.3 50 volt before it hits the power amp. So this is a DC blocking capacitor. Actually, these are both DC blocking capacitors, and you're probably wondering why they use two of them, because they're back to back. They're if you look at the polarity of them, they're opposite each other, so that they're it's actually a bipolar cap. So that one was open circuit, I believe. It was 2 or 3 kilo ohms ESR, and it had capacitance was down in the 100-200 nanofarad range. So I changed that one out, and what I did is I changed its complement out in the other channel, which is down here. If I scroll down, I replaced C263 just so both those caps are equal. And then I found another bad cap. Where was it? It was back over here. C123 is another 3.3 microfarad 50 volt, and it's another DC blocking cap. And I found this one open circuit as well, and I replaced that one, and then on the other channel I replaced 173, just to keep them balanced and equal. But that's pretty much it for all the bad caps I found in this amplifier, even after looking at the protection circuits and the power supply. There was not much to talk about in this amplifier, but I think we got it going good now. Alright, I just want to end it there. So thanks for watching, and I know it's not a full repair, not a full restoration, but I just wanted to get this thing back into working form again. That scratchy pot was just driving me nuts, and I got that part fixed, so it's all good now. So anyways, thanks again, thanks for watching, and we'll talk to you again on the next video.